Another skill that students sometimes struggle with is taking a sentence description of a chemical equation and converting that to the actual names and formulas of the chemicals to represent the chemical equation. So we'll go through several examples of this here. And why this becomes difficult is it involves several things that we should have learned along the way, and one is our chemical names. Another is what elements are diatomic, and also balancing equations. So the first thing we have to do is read the sentence that describes the equation and figure out which ones are the products and which ones are the reactants. All right, so it says hydrogen gas and oxygen gas react to form liquid water. So water is the thing being formed, so that's our product. So our two reactants are hydrogen gas and oxygen gas. So we look at our periodic table and we find the symbol for hydrogen as H. But we have to remember which elements are diatomic, and that's our have no fear of ice cold beer. So H is our have, so this is a diatomic. And what we're adding it to is oxygen, and so that's our of. So it's diatomic, and it's going to react to form liquid water. All right, so H2O we should know is our water, right? So now we need to put in our states of matter, so it tells us that hydrogen is a gas, and we're adding it to oxygen gas, and we're forming liquid water. So we have the parts of our chemical equation and their states of matter, but if we quickly look at this, we don't have a balanced equation. So then we'd have to balance our equation, and the two things we're trying to balance are hydrogen and oxygen. So we're going to set this up and say over here we have 2 hydrogen, here we have 2 oxygen atoms. On this side, our water molecule contains 2 hydrogen atoms and 1 oxygen atom. So you can see at this point we're not balanced, and so when we're balancing, we're going to save the elemental things to the end and deal with our most complex thing first. So this water molecule, if we put a number here, is going to change the number of 2 different types of atoms. But we see that we have an odd number on this side and an even number on this side for oxygen, so this has to become even. So we're going to start by putting a 2 here. So now we have 2 water molecules, so we have 4 hydrogen atoms and 2 oxygen atoms. And now our oxygen is balanced, but our hydrogen is not balanced. So we're going to have to come over here and put a 2 in front of our hydrogen, so that gives us 4 hydrogen. We still have 2 oxygen. And so now we have our balanced equation at that point. And that would be how we would convert this written description of a chemical equation into an actual formula. So here we have another chemical equation described in words, and it says when a carbon dioxide gas is dissolved in an aqueous solution of sodium hydroxide, the mixture yields aqueous sodium carbonate and liquid water. All right, so we have to decide what are the products and what are the reactants. So we're mixing carbon dioxide gas and we're putting it into sodium hydroxide. So those are things reacting, and what's produced are sodium carbonate and liquid water. So we need to figure out what the formulas are for these names. And so when we see carbon dioxide, we see di. So we're talking about a type 3 compound where we have two nonmetals combined, and those prefixes di tell us how many of each. So we have 1 carbon and 2 oxygen, carbon dioxide, and it says it's a gas. Right? And we're dissolving that in an aqueous solution of sodium hydroxide. So we know that hydroxide is from your polyatomic table. It's OH with a minus, and sodium forms a +1 charge because it's group 1. So you have a +1 and a -1, so those are going to go together 1 to 1. So you have sodium hydroxide, and it's aqueous, so that's an AQ. And what's produced from this is a mixture of sodium carbonate and liquid water. So if we look at your polyatomic ion table, carbonate is CO3 2-, and sodium is +1. Right, and so if we do our cross multiplying, we need 2 of these for every 1 of those. So we need 2 sodium for every carbonate, and this is also aqueous. And then the other product is water, H2O, liquid. Right, and so that would be our quick conversion there. Right, and if we look, we're not balanced at this point. Right, because we have a 2 sodium here and only 1 sodium here. So we can go through the whole thing, or we can put a 2 there, and that should balance everything else. We have 1 carbon, 1 carbon, 2 sodium, 2 sodium, 2, 4 oxygen, 3, 4 oxygen, 2 hydrogen, and 2 hydrogen. So that should be our final balancing of that equation. All right, let's look at another description of a chemical equation and see if we can convert it to a formula. It is elemental zinc is added to an aqueous solution of hydrochloric acid to produce hydrogen gas in a solution of aqueous zinc chloride. So the things we're mixing together are elemental zinc and hydrochloric acid, and what's being produced is hydrogen gas and aqueous zinc chloride. So we look at our periodic table and find the symbol for zinc is Zn. All our metals except for mercury are going to be a solid. And we're adding that to hydrochloric acid, which is aqueous. And what's being produced is hydrogen gas. So our symbol for hydrogen is an H. But remember our have no fear of ice cold beer, hydrogen is diatomic, so we have H2. And the other thing we're producing is zinc chloride. So remember, zinc is one of those elements that always forms a 2+ charge. Chlorine is in group 7, so it's always going to have a -1, so we need 2 chlorine for every 1 zinc. So we're going to have ZnCl2, and we said that it is aqueous. Right, and if we look at our equation, we can see pretty quickly that we're not balanced. So we're trying to balance our zinc and our hydrogen and our chlorine. So here we have 1 zinc atom, 1 hydrogen, and 1 chlorine. On this side we have 1 zinc, 2 chlorine, and 2 hydrogen. So a bunch of odd numbers here and not over here. And what we can do is put a 2 here. Our number of zinc stay the same on this side. We still have 1 zinc atom, but now we have 2 hydrogen atoms and 2 chlorine. So now we have a balanced equation that matches that description above.